Hi everyone and welcome back to this series. In this video, we're going to simulate the 500 MHz low pass filter circuit that we connected in the previous video. We'll also look into two important simulations. We're going to do an S parameter analysis and then we're going to do a group delay analysis. And these simulations will help us understand how our filter behaves across multiple frequencies, specifically how our signals are transmitted, reflected, and delayed through the circuit. So first, we're going to do an S parameter simulation. We're going to plot the S11, S21, and S22 S parameters. And the first step to do any simulation is to create a new graph. So I'm gonna go to my project window. There's this graph section. I'm gonna right click and then new graph. We're gonna give a name for this graph. This is going to be for the pass band and stop band. It's a rectangular graph and then I can click on create. Now the next step is to add my measurement to this graph. I can either just directly right click on my graph and click on add new measurement, or I can go over here where this graph is now created. I can right click and then click on add measurement. This is a linear analysis. I want to do a part parameters analysis, which is the S parameters. The data source is my schematic, which is this one. And I want to plot the S11 parameter, so I'm gonna add it. I also want to plot the S21 parameter, and then I want to plot the S22 parameter. And then I can close this window. Now, if the circuit has not been analyzed, you can just click on the Analyze button over here, or you can click on Simulate and then Analyze. Now, if you want to change, for example, the limits of your axes, you can just double click over here and change your limit. Here I have the information for my graphs, for the different measurements on my graphs. Now, if you notice, the S21 parameter has a high magnitude before the cutoff frequency, and then it decreases significantly after the cutoff frequency, meaning that our signal is passing from the input to the output before the cutoff frequency. And the opposite can be said for the S11 and S22 parameters, meaning there's a huge reflection after the cutoff frequency, so that the signal cannot pass after 500 megahertz. Almost 500 megahertz. Now, the next simulation that I want to do is a group delay analysis. So the first step is to create a new graph as well for this simulation. Let's name it group delay. And then let's click on create. Now, group delay represents the time delay experienced by different frequency component of a signal as they pass through the filter. Now, in most filters, the group delay usually it peaks at the cutoff frequency, and that's because the transition from pass band to stop band is not instantaneous. So let's plot our measurement. Let's add it. It's a linear analysis, and it is the group delay over here. And I want to plot the S21 parameter. I don't want it in dB. Now, if, for example, you do not know what this measurement does, you can just click on the measurement.help. It will open a help guide to help you better understand what does this measurement do and how it is calculated. So here is an example showcasing what does the group delay do and how it is calculated. The same can be done for each of the measurements added. So let's click on add and then let's close this. And here I have my group delay, and it peaks at the cutoff frequency because the transition from pass band to stop band is not instantaneous. Now, if I want to see the different windows that I have, I can go to window and then tile vertical to plot them vertically, or I can click on tile horizontal to see my schematic and the different simulations. Now, sometimes graphs can become crowded with multiple measurements. You can disable some measurements if you want. So for example, you can go over here, disable this one. So now you can only see the S11 and S21 parameter. And if you want to see the S22 parameter again, you can just enable it again. The same can be done for graphs. So for example, you can click on disable measurement to disable this graph and just focus on this one. And we can just click on enable measurement again. Now that completes the simulation of our 500 MHz low pass filter. We looked at the S parameters to understand the transmission and reflections, and we also examined the group delay of the filter. In the next video, we'll explore how to tune the circuit and perform parameter sweep to optimize the filter response and meet our design targets. For now, thanks for watching, and I'll see you in the next video.